welcome to all of you. I am Rishali and today we are going to see what is the power electronics and its applications. So this is the introductory section in which we are going to see what is power electronics, goal of its, then linear electronics versus power electronics, a basic block diagram, then what is the power processor and what are the power converters, their classification, the interdisciplinary nature of power electronics, its scope, applications, and different power semiconductor devices. At the end, we will summarize the lecture. So, what is power electronics? Basically, it consists of three blocks: source, load, and the middle layer is power electronics. So, source is the input to the power electronics and the output is load. So the task of this power electronics is to process and control the flow of electric energy by supplying voltages and currents in the form that is optimally suitable for this load. So in simple words, I'll give you one example. Suppose you want to design a party wear dress of a black color and floral length. So consider this material as a source, that is input, and you are the load. So here designer or the tailor acts as a power electronics. By using source input, he or she will design or stitch the dress according to load's requirement, which is optimally suited for the user load. So this is the basic principle of power electronics. So in this case, this source can be AC outlet, battery, wall adapter, lab supply, generators, etc. So these are the in homes and business applications, or here you can see these can be a power sources, and the load may be sensors, DSP, micros, displays, motors, speakers, etc. So what power electronics device will do? It will convert the input signal according to the requirement or what is suited for this load. So it may convert AC signal to DC, DC signal to DC, that is high low frequency, etc. So I hope you have understood what is the basic principle of power electronics. Now we will see why this power electronics is needed. What is the goal? Efficient conversion, conditioning, processing and control of electric power using solid state semiconductor devices such as MOSFET, BJT, IBGT and SCR, TRIAC, etc. in order to supply high quality power to the load, it is a user load, causing minimum pollution of environment and the utility supply circuit. So this is the goal of a power electronics here, to supply high quality power to the load is the important thing by processing, conditioning, converting the electric power. Now we will see how this power electronics differ from the linear electronics. So linear electronic processes in the form of signals, whereas power electronic processes in the form of energy, that is power. Then semiconductor devices generally work as controlled sources in the linear region of their characteristics, whereas in power electronics, semiconductor devices generally works as switches. Linear electronics deals with the active mode of transistors, whereas in power electronics, cutoff region and saturation region of transistors are important. Linear electronics focuses on information processing with minimum loss, but in case of power electronics, it focuses on the power conversion at highest efficiency using very small control signal. So this is how linear electronics and power electronics differs from each other. Now I will see the basic block diagram of power electronics system. So here you can see the power input to this power processor is usually electric utility at a line frequency of 60 or 50 Hz. It may be single phase or three phase. The phase angle between input voltage and current depends on the topology and the control of the power processor. The processed output, it may be voltage, current, frequency or number of phases, which is desired by the load, is denoted as V0 in this diagram. So Vi and Ii are the input signals, whereas I0 and V0 are the output signals. This feedback controller compares the output of the power processor unit with the reference or desired value. And the error between these two signals, that is the output signal and the reference signal, can be minimized by controller. So it controls the signal which is given to the power processor. So basically, what is the principle of this block diagram? To process or control the flow of electric energy by supplying voltage and current which is optimally suitable for this user load. Now we will see what are these power processors. So classification of this power processor depends on input or output form of the frequency. In most of the electronic system, the input is in the form of electric utility source. Depending on the application, the output to the load may have any of the following terms. The output may be DC, regulated or adjustable magnitude, or it can be AC of a constant frequency adjustable magnitude or adjustable frequency adjustable magnitude. The utility and the user load are independent of each other. It may be single phase or three phase. The power flow is generally from utility to the output load. There are exceptions also. In some systems, the direction of power flow may be reversible depending upon the operating conditions. Now we will see what are the power converters. So the power converters are the heart of this power electronic system. These are the building blocks of power electronics. These power converter uses semiconductor devices controlled by the signal in electronics, that is ICs, or inductor capacitor like energy storage elements. So again, based on the form of frequency on the two sides, input side and output side, these converters can be divided into following categories. If the input is AC and output is DC, then it is called as a rectifier. DC to AC, then it is an inverter. If it is a DC to DC, then it is called as a chopper, and AC to AC is a cycloconverter. So these are the four types of converter, or we can say topologies of the converter. Now I will give you one example. So here you can see this is a block diagram of adjustable speed AC motor drive. So as shown here, okay, I'll show you simplified diagram in next slide. So here you can see the same diagram of adjustable speed AC motor drive. So here it consists of two converters. The first converter, if you observe, so the converter 1 is operating as a rectifier because it is converting line frequency AC into DC. So it is a rectifier. Whereas the converter 2 is operating as an inverter because it is converting DC supply into AC supply. So this is how the power converter works. And what I said in last slide, that the flow of current may be reversible. So in this case we can see that the flow of power in the normal mode is from the utility input source to the output motor load. But during regenerative braking, the power flows in the reverse direction from motor to the utility. So when this regenerative braking happens, so when the power flows in the reverse direction from motor to utility, in this case converter 2 operates as a rectifier whereas converter 1 operates as an inverter. As I have told earlier, so in this the energy storage device, that is this capacitor in the DC link between two converters, decouples the operation of these two converters on its instantaneous basis. So again these are the power converter topologies and these are the symbols. I have already told you about this: chopper, inverter, rectifier and cycloconverter. So in further units we are going to study these topologies in detail. So power electronics can be used in many fields of electrical engineering. So here you can see it includes circuit theory, system and control theory, signal processing, electronics, electromagnetics, power system, electric machines, simulations and computing, solid state physics, etc. So combining the knowledge of these diverse fields make the study of power electronics challenging and very interesting. These are many potential advances in all these fields that will improve the prospects for applying power electronics to the new applications. And now talking about the industrial applications, power electronics can be used in automotive, healthcare, aerospace, renewable energy, consumer electronics, etc. So you can explore and find how this power electronics is used in all these applications. It can also be used in transportation, heavy industries and electric power generation transmissions, home appliances, portable electronics and so on. So there are numerous of application of this power electronics. I couldn't list all of them here, so you better explore more. So our first unit is based on study of different power semiconductor devices. It can be controlled or uncontrolled. So this is the broad area classification of power semiconductor devices, in which we are going to study SCR or triac, IGBT, MOSFET, etc. Also we are going to study different power topology converter in further section. So summarizing this session, what we have seen in this: what is power electronics, what are the goal of power electronics, how this power electronics differs from the linear electronics, what is power processor, what are the power converters, their classification on input output forms, then interdisciplinary nature of power electronics, what is the scope of it and what are the different various applications of power electronics. At the end we have seen the broad classification of power semiconductor devices. So in coming lectures we are going to study these power semiconductor devices in detail. So stay tuned till that. Thank you, stay home, stay safe and happy e-learning.